Okay, hi guys. So in this video, we'll be starting off seeing some of the, um, or rather, we'll be seeing some practice examples on the concepts which we have discussed in the previous lectures. So let's see uh, if you are able to relate the products coming out of the substrates and reagents or not. Okay, so this is some practice session. We'll be first seeing some practice on the previous problems, and then we'll be moving on to the cyclic structure of glucose. Okay, so let's start. So we have something like this structure or a substrate or a compound ester. Then what happens when we actually pass basic medium or OH minus to react with this ester? Obviously we have discussed it that it will form acetate ion plus it will form CS3OH. Why alcohol is not dissociating into CH3O minus and H plus? Because alcohols and ethers are stable in basic medium. Okay, let's discuss another example, another practice question. So we have acetic acid. So you have to tell how this acetic acid can be used to form something like this and OH here. So obviously first we'll be reacting with it with PCl5, which will help us form it something like acid chloride. And then in acid chloride, what will we be doing? In acid chloride we will be passing on first 2 moles of CH3 MgBr and providing acidic medium. It will form the following product. Okay, let's discuss third practice example. So what actually happens when we actually pass another acetic acid with in presence of CaOH whole twice and we heat it in presence of calcium oxide? So we'll get something like this compound as a product. Okay, so just think how can it be done, or we have actually discussed this example. So how will the mechanism look like? So I think if you are not able to recollect, then please visit the previous lectures in which this reaction was discussed, but still I will give you a hint in which 2 moles of CH3 OH will come together, calcium oxide will come together, calcium will attach to these two oxygen atoms. Okay, and obviously calcium oxide, the water molecule will be removed. After the removal of the water molecule, this oxide and this oxygen will come and attach with this CaO, and then the elimination of CaCO3 will take place, and finally one of the CS3 will get attached to this carbon, this CO bond, or this CS3 will attach to this C double bond O bond. As the both compounds are symmetrical, I will just say that this CS3 will go and attach to this C double bond O, and meanwhile what will happen is CaCO3 will eliminate itself from the compounds. Okay, so with this note, let's actually return back to our um, chapter of carbohydrates, and let's discuss about cyclic structure of D-glucose. So let's start with the cyclic structure of D-glucose. Okay, so now we have structure as this is the first carbon. Okay, and then we have a chain going on in which we have drawn this chain so many times that by now the structure of glucose should be clear to you guys. This is the sixth carbon atom. Okay, now what actually happens is this fifth carbon atom, the OH attached in the fifth carbon atom forms rather what you can call ether group by attacking to this carbon atom, and as a result we'll be getting something like OH and H here. Obviously we have acidic medium also, so this bond will come to the oxygen atom, will withdraw its bond and then attack on this H plus, and I'm not showing it, but you can use a different color. Okay, so as a result we'll be getting OH here on the first carbon atom, and then we will get a O link here. This is the first carbon atom, and the chain. Okay, so we'll be getting OH again here, H, so let's mark the carbon atoms. This is the first carbon atom, this is the second, third, fourth, fifth, and sixth. So this carbon atom is now here, which is actually formed a ether group with fifth carbon atom. So as a result, 6-member ring would be formed. Okay, so the nomenclature of this would be obviously D-glucose, and this we call as beta D glucopyranose. Okay, so we got it, beta D glucopyranose. Okay, so let's actually subject them to tolerance test. What will happen here? Both will give tolerance test. Obviously, because in tolerance test, this OH will also break down into this, rather ether group will also break down into C double bond O, and again aldehydes give tolerance test. Okay, what about reducing sugar? So reducing sugar is nothing but the test for reducing sugar is just similar to tolerance test. So whatever compounds are giving positive tolerance test, they will obviously give positive reducing sugar test. Okay, so both will give positive reducing sugar test. What about oxazone formation? If this gives, then it will also give. Why? Because oxazone formation takes place in basic medium, in which we'll again get aldehyde group on both the carbon atoms. Okay, what about mutarotation? Again, we will discuss the concept of mutarotation in the coming lectures, but for now you can note that both of the following compounds will give mutarotation. Okay, now for some of you who might be wondering that alcohols and ethers are stable in basic medium, we have told it, or I have told it so many times, then why actually this beta D glycopyranose or glucopyranose is also showing the tolerance test, reducing sugar, or oxidation formation, even though all of these actually happens in basic medium, then wouldn't be stable in the basic medium? The answer is no. Why? So if you can just see that this is not a ether group. If you look at this carbon atom, this is a hemiacetal group, because on one side the oxygen atom is attached to another carbon atom, and on the same carbon atom OH group is also attached. Hence this is a hemiacetal, not a ether. Okay, so hemiacetal actually gives this test by converting itself into a aldehyde first in basic medium, and then giving all the required tests. Okay, so this is not a ether, this is a hemiacetal. Okay, so regarding mutarotation, we will be discussing mutarotation in the next coming lectures, but as of now I'm not going into the details of it. So with this we come to an end of this lecture, or rather let's see some alpha D glycopyranose also in this example only. So what will we be getting? So actually this OH should be on the left hand side for the compound to be called a beta D glucopyranose. Okay, now what will happen is, if we have something like this structure wherein we have, okay, let me redraw beta D glycopyranose and alpha D glycopyranose, and then we'll understand. So we had something like this. H, OH, H, and OH here. Okay, this was our beta D glycopyranose, and if we actually This was beta D glucopyranose. Okay, and what about this structure? This would be, if we actually replace this H with OH here and H, rest of the, just draw the same below ring as below chain as the beta D glycopyranose, then we'll be getting something like this is structure, which would be alpha D glycopyranose or glucopyranose. Okay, so this will also show tolerance test and reducing sugar, osazone formation and mutarotation. Okay, then what actually happens in if we pass H plus in basic medium, then what will actually happen is if we pass on this alpha D glycopyranose H plus in basic medium, then what will happen? This is passed on CS3OH. Obviously, we are passing methyl alcohol also, and acidic medium. What will happen is this OH will attack on this H plus. As a result, this would be a positively charged carbon atom, or a carbocation would be formed. And why this carbocation would be stable? Because of the formation of our highly stable IIT cation intermediate. So I'm just directly drawing the product. This would be something like CS3OH here. Okay, and on this product actually, is the tolerance test possible? No. Why? Because the formation of aldehyde will not take place at this carbon atom. Why? Because this is now a ether group. Now what I was telling that alcohols and ethers are stable in basic medium, hence it will not show any of the test, because it's a ether compound and it's a alcohol. Not means directly, this is not a hemiacetal, as in we saw that OH is directly attached to this carbon atom, which is not the case here. This is not a hemiacetal, this is a perfect ether. Okay, so now it won't show any of the tests. Okay, so I hope you enjoyed this lecture. We'll meet in the next lecture. So till then, good luck and goodbye.